All right, so this lesson is all about planes in space. And the first thing you need to understand about planes in space is that planes in space are actually defined by their normal vector. That's the vector that's perpendicular to the plane. And the reason that is because when you think about a plane has infinitely many directions inside of it, but really only one perpendicular direction. So the equation of a plane in space is defined by its normal vector ABC and any point on the plane x1, y1, z1. So you have a times x minus x1, b, y minus y1, c, z minus z1 equals 0. And often we write that as a general form where basically we distribute the a, b, and c, and we get an equation ax plus by plus cz plus d equals 0. But what you need to really also understand about this is compared to our lines notes, where lines are a set of three parametric equations, a plane is just one equation, the plane equation, with an x, y, and z all inside. So basically what happens is your coefficients come from the normal vector, and the coordinates of the initial point is subtracted from your x, y, and z inside of each parentheses. So if we were to write the equation of a plane normal to 2, negative 7, 8, and passing through 5, negative 1, 0, I'd get 2 times x minus 5 minus 7 times y plus 1 plus 8 times z minus 0 equals 0. So there's one form of the plane, and then if we distribute, I have 2x minus 10 minus 7y minus 7 plus 8z equals 0, which is really 2x minus 7y plus 8z minus 17 equals 0. So two standard forms of a plane, super easy to work with. You just need a vector and a point. Right, both forms of the equation of a plane passing through 3 points. All right, now there's a lot more to do in this question, and the reason this question is second is because if you think about a line is defined by 2 points. A plane is defined by 3 non-collinear points, because as soon as you add in that third point, the best you can do is a triangle, and a triangle exists on a plane. So if I have 3 points, I still need those same initial things to write the equation of a plane. I need a perpendicular vector, and I need a point on the plane. Well, congratulations, I have 3 options for the point on the plane, but I don't have any normal vector. What do I do when I need a normal vector? Well, we do a cross product. So what we're going to do is we're going to call these, let's say, A, B, and C, and we're going to cross A, B, and AC to get a normal vector, or any other pair that you want. So if I call this A, B, and C, vector AB is going to be negative 1, 4, negative 10, and AC is going to be negative 2, 10, 13. So if I cross AB with AC, I have negative 1, 4, negative 10. I have negative 2, 10, 13. And I cross them. 4 times 13 is 52. 52 plus 100 is 152. We got big numbers here. Minus j. Don't forget, you've got to negate that j component. Negative 13 minus 20 is negative 33. And then plus k, and this is going to be negative 10 plus 8 is negative 2. So I end up with the vector 152, 33, negative 2. So the equation of my plane is going to be 152 x plus 2, 33y minus 10, minus 2z minus 13, and that all equals 0. It says to write both forms, but let's be honest, nobody wants to distribute that, neither do I, so we'll just leave this in the one form. Yes, there's another, but we don't really care right now. Write both forms of the equation of a plane containing these 2 lines. Well, let's think about this visually. If I've got a line right here, And I have another line right here. The equation of the plane passing through both of them would have to have a normal vector that looks like this. I need a normal vector, which means I need a cross product. That cross product would be from the direction vectors of these two lines. The point on the plane could come from the initial point of either line. So I need a cross product of, I'll call it L1 and L2. So I have I, J, K. L1 is 2, -7, 1. L2 is 1, 5, -1. And if I cross them, I get 7 minus 5, which is 2. -2 minus 1 is -3. And 10 plus 7 is 17. So my normal vector 2, 3, 17 gives me 2x, let's see, now my initial point here would be -3, 8, 0. So it's going to be 2x plus 3 plus 3y minus 8 plus 17z minus 0, which is going to be 2x plus 3y plus 17z, and then I have 6. Take away 24 is -18. So there's my two plane equations. Find the point of intersection of a line and a plane. All right, so here's a little bit different. Instead of writing the equations of planes here, we're talking about where lines and planes meet. So if I have a plane like this, and I have a line that jumps through it like that, and I want to know where they intersect, let's look at this line equation. I have an x equals, a y equals, and a z equals. And let's look at a plane equation. I have an x, I have a y, and I have a z. Well, normally when we want to find where two things intersect, we set them equal to each other, but we never really set things equal to each other when we're solving for intersections. We're always doing substitution. So even when you were back in algebra and you had like y equals 2x plus 4, and then y equals 3x minus 9, and you don't know where they cross, we always said, oh, you set these equal. You didn't really set anything equal. You took this 3x minus 9 and you substituted it in for this y. Well, that's what we're going to do here, is we are going to substitute. I have an x, a y, and a z in the plane equation, and I have an x, a y, and a z in the line equation, and those three things are in terms of t. So I have 3 times the x expression plus 7 times the y expression, 8 minus 7t, there we go, minus 3 times the z expression equals 1, not 0, 1. So all I did is I substituted 2t minus 3 in for x. I substituted 8 minus 7t in for y, and t in for z. So when I distribute, I get 6t minus 9 plus 56 minus 49t minus 3t equals 1. 6t plus negative 49t is negative 43t. Minus 3 more is negative 46t. Negative 9 plus 56 is positive 47. That equals 1. If I subtract 47, I get negative 46. If I divide by negative 46, I get 1. That tells me when t equals 1, this line intersects that plane. So now I'm going to plug t equals 1 in for all those t's. So x equals 2 times 1 minus 3. Y equals 8 minus 7 times 1. And z equals 1. So they intersect at the point negative 1, 1, 1. Long story short, when you want to know when a line and plane intersect, you simply substitute the plane equations substitute the line equations into the plane. Solve for t, plug it back in, and you're good to go. All right, last one here. Find the line of intersection of two planes. So this one, again, let's visualize. So if I have this plane, and then I have another plane that's going to meet up with it, they're going to meet up, and when they intersect, they're going to form a line. Okay, so think of two pieces of paper that you stick up against each other. If you put paint on one, you draw a line on the other. So if you want to find a line of intersection of two planes, the first thing you need to do is turn the two vectors of these planes into the one vector of the line. And in layman's terms, if I need to turn two vectors into one, I do a cross product. Now, why does that work in this case? Well, what's going to happen here is I have the normal line from this plane coming like that. I have the normal line from the other plane coming like that, except he's kind of, going back to here. When I cross the two of them, I'm going to get the direction vector of the line of their intersections. Basically, two perpendiculars make a direction vector for the line. This is a lot easier if I could stand in front of you and show this, but trying to draw on the 2D surface here that I have in front of me, not so much. But long story short, if you want to find the line of intersection, the first thing you got to do is you have to cross the plane vectors. So I'm going to cross P1 and P2. And I have I, J, K, 2, negative 3, 8, 3, 7, negative 3. And when I cross them, I have 9 minus, there we go. When I cross them, I have 9 minus 56, which is negative 47. Minus J gives me negative 6. Minus 24 is negative 30. Plus K, 14 plus 9 is 23. So I have negative 47, 30, 23. That's the direction vector for my line. Now here's the tricky part. Now I need a point on the line. Now, most lines in space are going to cross every x, every y, and every z coordinate at some point, because most lines in space are oblique. They tilt left and right, they tilt up and down, and they tilt forward and backward. So we kind of prey on this in order to find a point that's going to be on the line that we're solving for. So what we do is we say, let's assume that this line of intersection does hit every x, every y, and every z at some point. I'm going to say, let's find the point when x equals 0 on that line. So we're going to let x equal 0, and we're going to let x equal 0 up in these equations. So if I let x equal 0, this reduces down to negative 3y plus 8z equals 2, and 7y minus 3z equals 1. Now all of a sudden, instead of 2 equations and 3 unknowns, I have 2 equations and 2 unknowns, which is solvable. So I'm going to multiply this guy by 7. I'm going to multiply this guy by 3. This is going to become negative 21y plus 56z equals 14. And this is going to become 21y minus 9z equals 3. Add them together, those cancel. This becomes 47z. That number 47 has come up a lot today. And then down here, this is going to be equal to 17. So z equals 17 47ths. Ew. Whatever. So there's z. Now I need to solve for y. So 7y minus 3z equals 1. So 7y minus, let's see, 17 times 3 is going to be 51 47ths equals 1. If I add 51 47ths, I get 7y equals, what's that, 98 47ths. And then if I divide by 7, y is going to equal 14 47ths. So the line's vector is right there, and the point on the line is 0, 14 47ths, 17 47ths. And now that I have all that, I can finally write the equation of the line, which is going to be x equals negative 47t plus 0, y equals 30t plus 14/47, and z equals 23t plus 17/47. Whew. So that is how you find the equation of a line where two planes intersect. We've done a lot today. We've done three things. We've talked about how do you write the equation of a plane, and we said you need a normal vector and a point. We've talked about how do you figure out where a line and a plane intersect, and that's a straight substitution. And we've talked about how a plane and a plane intersect and form a line. So hopefully all of that makes sense. What you really need to remember is it all boils down to what do you have, what do you need, how am I going to get it? All right, and we always end with a joke here. So the joke today is going to be, why did the scarecrow earn a medal? Why did the scarecrow earn a medal? Because he was outstanding in his field. I know that one was really bad, so I'll give you one more really bad one to go with it. What's an elephant's favorite vegetable? Squash. And I'm sure some of you are going to want to argue with me maybe in our discussion questions about, well, isn't a squash really a fruit? Whatever. Call it a fruit, call it a vegetable. Still, the elephant squishes it. Have a wonderful day, evening, morning, whatever time it happens to be. And we will speak again soon about distances between lines and planes in space.